Okay, now we're going to take a look at the cylinder, which to do that, we'll go up here to the Shapes icon, and under Shapes, grab the Oval tool. We know the bases of a cylinder are circles, but you would never see the perfect circle on a cylinder unless you were looking at it directly from the top or bottom. So talking about perspective, we would see the bases of a circle in an oval shape. That's exactly what we're going to draw, is a nice oval shape here. Or not. There we go. Go ahead and get rid of that fill. And of course we want the two bases to be congruent. So we will copy and paste. And you want to make sure that we're going to place the oval, the second oval, in a spot so that when we connect the outermost edges to each other, that the height is going to be perpendicular to both bases. We don't want to put the oval over here because when I connect these outer edges, the height will not be perpendicular to the two bases. We call that oblique, and a lot of people immediately think of the Leaning Tower of Pisa in Italy, but that is not an example of oblique in real life. It's easy to think that because it looks like the height is on a diagonal, but if you look at the bases are not parallel to the ground. They once were. At one point, the Leaning Tower of Pisa was a cylinder-esque type shape. All it is now is just literally leaning, rotated, if you will. So that does not make it oblique just because it's been rotated. If we take our second oval and drag it over, we see we've got these red lines to our advantage. That giving me the clue that we are perfectly in line with the one that is below it. We will use our line tool to connect the outer edges, like so. And do the same for this side. Of course, if you wish to zoom in to have better control, you can use the magnifying glass up here near the top left-hand corner. Now, the last thing we need to do is to draw our radius, which, much like the sphere, I am going to go ahead and zoom in. Pardon all the little clicking and slight lunkiness on my part as I am using a laptop to make this happen. We've got these little circular guides, which if we connect them, that will show us the exact center of our circle. It's right here. So I can go ahead and come back over here, grab it, drag it right to the center, and then immediately delete that line that I do not need. Go up to 100% here. Okay? So there is my cylinder. Okay? So now, the two dimensions of a cylinder that we need are going to be a radius and a height. And I will erase all that stuff from my test run. The radius is right here. And we'll go ahead and make our radius 3 inches. My apologies in the sloppy writing. As you previously saw, I'm having to use my fingertip on an iPad to draw this today. So this is pretty interesting. And our height is going to be not quite double that. I would say maybe it's a little bit more than that. What, 4 inches, might you say? So you might say 5, and that's acceptable as well. I think 6 is way too much. So we've got our radius of 3, or what appears to be a 3 on the screen, inches, and a height of 4 inches. Let's talk about the volume for a moment. The volume of a cylinder depends, first of all, on the base, which we know to be a circle, and the area of a circle is pi r squared. So we're going to start there with pi times r squared. And then we have to multiply that times the height. It's just that simple. Pi times r squared times h. Of course, once we plug the numbers in, we'll follow our order of operations starting with the exponent and then followed up by all the multiplies, getting a number with an infinite decimal because we're multiplying by pi, and make sure that we are rounding to the hundredths spot. Let's talk about the surface area. I'm going to develop this equation here, so bear with me. Okay. Surface area, of course, as we talked about previously, is going to be the area of all the faces added together. Well, we know the base is a circle with an area of pi r squared. And we've got two of those circles that are the exact same size, so we're going to start there. 2 times pi, that's pi, just believe it is, r squared. Okay? I want to make that pi look better, but I feel like I'm going to butcher it, so I'm not going to touch it. But that is a pi. And then, we mentioned this briefly before, if you take a cylinder and kind of cut right down the height, one of the heights, and you kind of unroll it and flatten it out, it's going to be a rectangle, which we know the area of a rectangle to be base times height. Well, the height is the height, but the base is actually the circumference of the circle base. And we know the circumference of a circle to be pi times diameter, which is going to be helpful for us to relate it to radius instead of diameter. We know the diameter is twice the radius, so the circumference could also be 2 times the radius times pi. Okay, so we'll start there. The circumference of the circle is 2 times pi times the radius. But that is just going to be the base of our rectangle. We still have to multiply that times the height. Of course, we add that to our previously found surface area. So we've got this big lunky equation, right? Not just because of the way that I've written it with my hand terribly, but because it just looks like a lot. You can actually simplify this by doing greatest common factor. Can you point to the greatest common factors on the screen? Okay, so I'm not Dora, but I think you can see that each of these terms has a 2, a pi, and 1 radius. The first term has a radius squared, but the second term has only a singular radius. So we can greatest common factor out a 2, a pi, and a radius. So our equation now would look like this. The surface area equals 2 times pi times the radius times the quantity of the radius plus the height. That's actually pretty good. That's what happens after we greatest common factor out the 2, the pi, and the radius. Okay? Again, plugging numbers in, we would start order of operations wise with the parentheses, doing the addition inside. After we complete that, it's all a bunch of multiplication left over, which we can do left to right. By the time we multiply by pi, we've got ourselves an infinite decimal throughout the whole thing, rounding to the nearest hundredth spot. And then make sure we put our units on each of our answers. Volume, inches cubed in this case, and our surface area would be inches squared.